Chapter 4, you went through and you did code listings, and a lot of you are really happy about, oh, look, I made a note. Don't forget test data with algorithms. You're really happy because you're familiar with what's going on in this chapter. Again, we're flying right through this. We're doing a chapter a day right now. Okay, thanks, Ryan. So if I take a look, going back to review, we talked about, for my students, this was an 8-point test question. 4 points was, what are the relational operators? Less than, greater. Again, we have algebra operators. Now we have relational operators. We had 2, 4, 6 of them. This one was the not equals. What did we say? It compares expressions. Result was Boolean. Nice and easy. We know what algebra expressions are. X is an expression. 2 times x plus 3 is an expression. There's no equals in it, so it's not an equation. Compares expression, results Boolean. Then we had our logical operators. Not, and or. And you talked about truth tables with these. So hopefully those of you who did not have me for 121, you did all of this. This time we're comparing Booleans and the result is Boolean. Now, why did we cover all this? Because we got into our if statements. We have if blocks. We have the parentheses after the list that should evaluate out as true or false. In our world, we looked at something where we came in and asked a question. And if it was true, I did something. If it wasn't true, I just moved on in the program. Okay, it's called a single alternative. There was one option of doing anything. Second one was the double alternative. This is where we came into the if, we had a block, we had an else, and we had a block of code. Remember, I only needed the braces if it was more than one line. If there was one line, I could get away without the braces. Single alternative, double alternative. Hopefully we're just knocking the rust off. A quick note. Don't confuse the equal operator with the assignment operator. Okay, round 2 in this world, don't ever get those confused. It happens. It really does. We had a problem with Java when I tried to do the equals. What was it that I couldn't do to see if they're equals? Comparing integers? No, I could see if integers were equal. Comparing no, doubles were good. Which one did I have trouble with?
Floating points?
Nope, not floating points. Starts with, what's that? Strings, right? Strings. So we're going to have to find out shortly, will the equal work to compare strings in C++? Back in Java, we had to use a method called
compared to.
Excellent, Dario. Yes, excellent. Compared to. Yep. All right. Moving right along with it. Then we moved into nested ifs. And a nested if was statements inside of if-else blocks, and they could be if statements if we wanted to. And you typed up code listing 411 and submitted it, so you did see an example of that. We also like the if-else if statement. Instead of indenting, we left justified them. We would end up with a default statement, which was just the else. That was kind of nice because we did things like, if grade is greater than 90, then print an A. If grade is greater than 80, print B. If grade is greater than 70, print, you're barely getting by. Else print, you fail. Nice. And again, we mentioned about strings. We had dot equals, but guess what? In C++, the equal will work. So we will be able to compare. In Java, when I did this, what did it compare for the string? Not the string's values, Nathan?
The reference.
The addresses, right? It was called a reference variable. It just compared the addresses. So still moving along with decision statements, we started to get cleaner ways of writing things with if, nested ifs, if else's. And finally, we ended up with the switch statement. And taking a look at the switch statement, you're going, okay, yeah, I kind of remember the switch statement. Some terminology inside of the switch statement, I had a data type. And the data type was fine, but it had to be an ordinal data type. As you can see, it's one that has a unique predecessor and a successor. That means something comes before it. So int is ordinal, because if I said 23, what comes before 23?
22.
22. What comes after 23?
24.
24, right? So if I put a variable in here and it was an int, I was okay. And I could come down and I'd have my case statements. And in 121, you were quizzed quite a bit on the break. Sometimes you put a break in if you want to break all the way out. If you didn't want to break out, you didn't put the brace in, but it would dribble down into the next case statement. Int is an ordinal data type. Boolean, is that an ordinal data type? What comes before true?
False.
What comes after true?
Nothing.
False. Yep, it just keeps wrapping around. Okay, true and false and true and false. It'll just keep wrapping around. What about char? Could I ask what comes before? Well, chars are easy. I would just have to reference the ASCII chart because it has all the numerical values for chars. So there's going to be one that comes before doubles. What comes before 2.1?
2.0.
2.09, maybe. 2.099999. Now, double is not an ordinal data type. So doubles, yeah, we're not going to have any luck up here. Okay. Quick review. If you did all the code listings, everything in here should sound familiar. I just wanted to dot the I's and cross the T's. Okay, the next thing you see, I say page 192. So I'm jumping in my book to page 192. All right, I have a note in here, Naxo, and the X is sort of there, it's sort of not there. And I occasionally will get students that will ask about order of operations. And when it comes to the Boolean operators, Boolean being true or false, it follows this order. They're not all the same. It'll do the nots first, it'll do the and statement second, and it'll do the or statements third. Now I have an X in there for a reason, because there's something called exclusive or. And that works like or except for both. Both isn't going to work. So remember, or is one or the other or both true, then the whole thing is true. This one is only one or the other is true, not both. So there is an order of operation. Okay, so I have 2, 4, 6, 8, 10 of those. Can you go through and maybe on a piece of paper or something beside you, check them out and see what you get? Do 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 do. Hey, we have perfect attendance today, folks. Good job. All right, first one, true and false. What is it?
False.
False. Number 2, true and true.
True.
False and true.
True.
False.
False and false.
False.
Okay, good. So we have those 4 done. What do I have for the next 4? I have true,
True.
true,
True.
true, and
True.
last
False.
one is false. Good. And then these are kind of easy. the not of true, the not of false. They're just the opposites. All right, good. Questions on those? You're starting to get to the point where you've seen truth tables a lot. 419. See what you can get for answers there. See, the first one becomes false or true. False or true gives me a
True.
true. Good. 6 is less than C or equal to. That's a true. And I'm going to end it with a false. True and false.
False.
False. Good. 1 not equal to B. That's true. C is not equal to 3. That's true. So now I do true and true. I got it true. Why am I doing? You just tell me what the answers are. D.
True.
True.
True. I heard a couple of trues. Anybody want to fight that?
True.
Good. And the last one.
True.
True as well. Okay. Just wanted to run through that exercise just to make sure everybody is good with those logical operators. Next thing, I have a note, page 222. We're going to do some problems. I'm going to put you in breakout rooms. You're going to work on those. On 222, I'm going to have you do problems number 2, 5, 7, 8, and 15. In number 2, I would like you to use a switch statement. If I go to that page, 222, number 2 is a Roman numeral converter. Nice and easy. You're using a switch statement. 5 is body. So these are all going to be short little blips of programs. I want you to work together when I put you in breakout rooms. Have somebody share their screen, and that person who shares the screen, they type, the other people talk and go through. So there's a bunch of quickie practice mini programs to make sure you're up to speed with doing decision making in C++. Are there any questions? As you finish them, I'm hoping that some groups will post them. Can you put them all in one program? I'm fine with that, like you did the other day. That way you have examples to look at and review through them.